students, this is our third video on circles, and what we're going to actually do now is find a function rather than a relation in this subject. So once again, a full circle given by the equation x squared plus y squared equals 16, for example, that's a relation, but it's not a function, because for most of the values for x, there are two different values for y. But we can make it into a function if we're happy to just draw the graph of a half a circle or a semicircle. So let me show you exactly what I mean. So there's the equation of a circle, and all we have to do to make it into a function is to make y the subject. So stop the video and see if you can do that on your own, and then start the video to see if you got it correct. So what I did first is got the y squared by itself on the left by subtracting x squared from both sides, and just take the square root of both sides. And one thing you have to remember is you actually have two different solutions when you basically get rid of the square. You can have positive square root of 16 take x squared, and you can have the negative square root of 16 take x squared. So basically, the positive one is the upper semicircle, and the negative one is the bottom semicircle. So basically, I've come up with two functions that together will make the entire circle. Now here's something that I'd like you to try on your graphics calculator, and you might get a surprising result. So if you went ahead and typed in that equation into y1 and that equation into y2, and then go ahead and draw the graph, here's what you might see. Oh, that doesn't look like a circle at all. That in fact is the shape of what's called an ellipse. And the reason for that is, on our calculators, the distance from a distance of 1 horizontally typically is different to the distance of 1 vertically. So if you actually want a distance of 1 in the horizontal direction and in the vertical direction to be the same, so this does look like a circle, then you have to, I'll just show you the answer at the bottom. You've got to basically press the zoom button on your calculator and then go press number 5 for zoom square, and that will give you a square version of it, which will give you a proper looking circle. The other thing to notice is part of the graph is missing. So for these points here, because the graph is essentially vertical, for some reason our calculator can't draw that. Anyhow, so here's what I did. Here's what I ended up with once I said, let's square it up. And it looks pretty good, but once again, it's got gaps close to the x-axis. So our calculator is not all that wonderful at drawing circles. What it's actually done here, of course, is it's drawn one semicircle, which is that function, y equals square root of 16 take x squared, and it's also drawn that semicircle, which is y equals negative square root of 16 take x squared. And that's what you have to press on your calculator to get it to square it up. Okay, what's this? I forget what this is all about. Make y the subject. Okay, so we're going to do the same thing, but in this case we've got a circle that's not centered at the origin. It's centered at 2, -3 with a radius of 4. So once again, stop the video, get out your pen or your pencil, and make y the subject of that, please. So let's see how you went. Okay, so once again, I got the y all by itself, or well, the expression involving y all by itself on the left-hand side by subtracting x take 2 in brackets all squared. Once again, take the square root of both sides. That gives us plus or minus the square root of all of that. And of course, the square root and the square cancel out on the left, which gives us just the y plus 3. And finally, we need to get the 3 on the other side, and I like to put it in front. So I subtract 3 from both sides, and that gives me -3 plus or minus the square root of 16, take x take 2 all squared. So the square root of all of that. And once again, you can rewrite it as y equals -3 plus that, and y equals -3 minus that. And once again, to see the graph on your calculator, go ahead and type in those two functions just there, and this is what I came up with. Well, in fact, what I did there, basically, the question was only graph the positive semicircle, so I only graphed this one, and as you can see, it hasn't done a very good job. So that's actually, on that side, it looks higher than that side. So the calculator's not that wonderful at drawing graphs of circles or semicircles. Okay, try this one. Determine the equation of that semicircle. So I'll leave you to stop the video and try it on your own, please. Okay, so for this one, the center's at the origin, so h and k are both 0, so that makes it easy. The radius is 6, which you can get from that point, or that point, or that point. And therefore, we have a nice simple equation. H is 0, k is 0, radius is 6. And I've actually done the rearrangement of the formula already, and I get y equals negative the square root of 36 take x squared. And why is it negative? Well, that's because we've chosen the bottom semicircle, so we want that to be the negative square root rather than the positive square root. Okay, and I think we have one more page to go for this video. Try this one, please. Find the equation of that semicircle. Okay, the difference between this question and the previous one is the center is not at the origin, so the y-coordinate is still at 0, but the x-coordinate's gone back to -2. So that means we have h is -2, so x minus h becomes x plus 2, all squared. K is equal to 0, so y minus k just becomes y. And the radius, to go from -2 to -2 to -5 is 3, so the radius is 3. And then all we have to do now to turn it into just a semicircular equation, that gives us the whole circle, is make y the subject. So we left the y squared by itself on in this case I left it on the left-hand side, move that to the right-hand side to get 9 minus all of that, and take the square root of both sides, and that gives us the equation for the semicircle on top. I've used the positive square root rather than the negative square root. And that is our second to last video. We have one more to go. We'll be looking at some of the slightly more challenging questions.